1.9, 3-set Venn diagrams. So now that we've worked with 2-set, we're going to go ahead and extrapolate and apply the same rules and the same logic to 3-set Venn diagrams. So 3-set Venn diagrams show the relationship between 3 sets of items, okay? The middle sections, I'm going to go ahead and do this in red here, okay? The middle section right here represents elements in A, B, and C. So they are common to all 3. And then when we work, we always work inside out. So then when we take a look at the sections adjacent to the middle, these are intersections of only 2 of the sets. Okay, so not all 3, but only 2. And these have a shape like this. Okay, so we have A and B, A and C, or B and C. So these are exactly 2. And then the larger sections here that are only labeled A, B, and C, these sections are elements only in A, only in B, only in C. Okay, so we can also apply the principle of inclusion and exclusion for the 3 sets. Okay, I'm going to do this in this second Venn diagram. Okay, so if we add all of the elements in A, all of the elements in B, and all of the elements in C, we can see that we've double counted. So we've double counted all of this. So then what we're going to do is we're going to subtract this double count here, this double count here, so A and B, A and C, and then B and C. But then here's the next issue. We've subtracted too many. Now we haven't actually included this middle section. So then we have to add that middle section back on. Okay, that's just for the visual. Now, the number of elements in A or B or C, so this is all, like in all of these, okay, we're going to add number of elements in A, number of elements in B, and number of elements in C. Okay, that's what we just said. But then we're going to subtract the doubles. We're going to subtract the number of elements in A and B, B and C, and A and C. But then we're going to add back that middle. So then we're going to add back the full intersection of A and B and C. Okay, so let's start with just reading Venn diagrams with 3 sets. So based on this Venn diagram to the right, we're going to state the following. So the number of elements in M. For M, we're looking at this entire section. We are going to add 10 plus 9 plus 2 plus 5. You can get 26. Okay? And remember, with this n, it's going to be an integer value. Okay? So now, what is the number of elements not in M? So we can go ahead and we can add all of the numbers that are not in that M circle. So we can add 6, 4, 21, and 12. And I get 43. Okay? What about M or L? So this is going to be all of the elements in M or L. And remember that fluff, like as long as it lands in M or L, we're going to include it. So in these 2 circles here, we're going to add up all of the elements. We already said M here was 26. So we can start with that baseline of 26 and then move on to add 4 and 21. I get 51. Okay, now the intersection of M and N. So this intersection is only here. This intersection, because like this notation right here, is going to be the overlap. As long as it's in both M and N, which is just 9 and 2, which is 11. Now we're going to venture out more. Let's take a look at 3. So, we already said that M or L is going to be that 51. Now, what about L or M or N? This time we're going to expand this to the N. Okay, we've already taken into account 9, 2, and 4. So the only number that we're actually having to add now is this 6. So we're going to start here, 51 plus the 6. So 57. Okay, now notation-wise, the number in L and M and N. This is the intersection of all three. So the intersection of all three is right in the middle. It's just 2. Okay, and now let's do the complement. These kind of go together. The complement of L or M or N. So we said M, N, and L are all 3 of these circles. So what's outside of these circles? Well, it's just 12. Okay. And the last one, what is the number in the universal set? Okay. So we actually already did a lot of this legwork, M, N, and L. And I mean, you can go over this and do 10 plus 9 plus 2 plus 5 plus 4 plus 21 plus 6. But we've already done that. It was here. It was 57. But then we also have to add this 12. Because as long as it's in this box represents our universal set. So we get 69. Okay, let's create a Venn diagram for the following sets. So integers from 1 to 20 is going to be our universal set. So that's the entire box. Now integers divisible by 4. Let's actually write these out, okay? So 4, 8, 12, 16, and 20. Okay, and then set B is 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then set C is integers divisible by 3. So let's go 3, 6, 9, 12, 15, 18. Okay, I'm going to go ahead and label these A, B, and C. And now we have to go inside out, okay? Inside to the outside. That's our method. So first we have to find integers in all 3. So I'm going to start with set A and set C. 12 might be it. Yep, 12's good. Okay, so 12 goes in the middle. And that's the only duplicate there. Okay, now what about an A and B? So A and B are these 2 sets here. Okay, 4 doesn't overlap, but 8 overlaps. 16 doesn't overlap and 20 doesn't overlap. So that's it. Okay. What about A and C? So 4, no, 6, 9, no, 15, 20, 15, 16, 20, 15, 18. Okay, there's not going to be anything in here. Okay, you don't put a 0, you don't have to put an X because then it's going to look like a variable. But I'm just going to leave that X in there just so that we know that we've done that work. Okay, it can be an empty set and that's okay. It's just called the null set. Now, B and C, so intersection. So we have the 6. We have the 9. And that's it. Okay, now let's go back to A and we're going to list all of the values in A that we haven't listed. 4, 16, and 20. So 4, 16, and 20. Done. A's done. B, 5, 10, 11, 13. Okay, 5, 10, 11, 13. And C, 3, 15, 18. 3, 15, 18. And now what we want to do is we want to go to the entire universal set and ensure that all the integers from 1 to 20 are accounted for. So we don't have a 1, so I'm going to put 1 here. We don't have a 2, but we have 3, 4, 5, 6. We don't have a 7. We should have a 7. It should be instead B. Oh, we left out this 7. This 7 should be here. Perfect. Okay. 8, 9, 10, 11, 12, 13. We don't have a 14, so we have to put that outside of the circles. 15, 16. I don't think we have a 17, 18, and then a 19. Okay, so this is our Venn diagram. Okay, creating a Venn diagram with 3 sets. So if you're given a bunch of information, my recommendation is to first list all of the information and then work our way from the inside out. So there's 140 students at Mathville High School. So just like the total in our universal set, it seems to be 140. Okay. 52 are taking advanced functions. So I'm going to put AF equals 52. 71 are taking data. 71. And 40 are taking calc. Okay. Now 15 are taking advanced functions and data. So advanced functions and data is 15. 8 are taking data and calc. So data and calc, and that's 8. And 11 are taking calc and functions. Advanced functions. Let's go 11. 2 students are taking all 3. So data and calc and advanced functions is going to be 2 students. Okay, so we're going to go ahead and illustrate the enrollments with a Venn diagram. By listing these, we don't have to go back to the original question. We're now going to go inside out. So in the middle, let's call this data, advanced functions, and then calc. So in the middle, it's going to be the 2. That one's done. Now, calc and advanced function is 11. So calc and advanced functions is going to be 11. So we've already taken into account 2. So we subtract that from the 11, and there's going to be 9 only in advanced functions and calc, but then not in data. Then 2 are also in data, equaling 11. Okay, data in calc, 8 minus that 2 that we already accounted for, and I get 6. Advanced functions in data, I get the 15 minus the 2, so I get the 13. Now, calc. This entire circle here has to account for 40 individuals. But we already took into account 6, 2, and 9. So there's 23 that are only registered in calc. Now data, 71. But we already took into account 13, 2, and 6. So 50 are only in data. And then advanced functions is 52, but we already took into account 13, 2, and 9. So that's 28. Okay. So if we were to go ahead and add all of these up, so this is the number of data or calc or advanced functions. So the number in all 3 of these circles, you can just do this in your calculator. You don't have to show it. Pour on to the next line. Okay. But if we have 50, 13, 2, 6, 28, 9, 23, I get 131. Okay. What that means is that our universal set has 140 in it. But these 3 circles only have 131. So if you just simply think 140 minus the 131, we have 9 individuals not taking any of the math courses. So for B, the answer is 9. Okay. Now let's actually talk about this principle of inclusion and exclusion. So we're going to do this the same way we did it for the 2 variable. But then this time we're going to do it with 3 set Venn diagram. And we're going to start from the inside out, okay? So 65 students participate at a school. 65 students at a school participate in 3 different extracurricular math. So the math club, the science club, and the art club. Okay, some students participate in multiple clubs, and of these 65 students, all of these 65 students participate in at least one club. I'm going to tell you, all this means is that the number outside here is 0. So all 65 students in at least one club. A survey was conducted to gather information about the students' club memberships with the following results. So we have 40 in the math, 35 science, 30 art. 20 in math and science, 15 math and art, 10 science art. So we need to figure out this middle number. We need to figure out the number of students in all 3 clubs. So that's the number in math and science and art. That's our goal. So let's work from the inside out. The inside is going to be an X. Now, science and art is 10. This is going to be 10 minus X. Okay, that one's done. Math and art is 15. So math and art is going to be our 15 minus X. Math and science is going to be our 20 minus X. Okay, now this is where it gets a little bit more tricky. So for the art club, we have 30 students. So 30. But we already took into account 15 minus X. We already took into account X. And we already took into account 10 minus X. We have to be able to bracket the 15 minus X and the 10 minus X, and then distribute that negative sign into the bracket. So if we want to see the work, we're going to have 30 minus 15 plus X minus 10 plus X. So our expression here is going to be 5. The X and negative X cancel, 5 plus X. Okay, what about science? Science is going to be 35 students. So let me put the work over here. So 35, but we already took into account 20 minus X. We already took into account X. And we already took into account 10 minus X. So let's go ahead and distribute that negative sign into the brackets. 35 minus 20 plus X minus 10 plus X. So 35 minus 20 minus 10, we get 5. X and negative X cancel. We get 5 plus X. I want to say that this question just so happens to have 5 plus X, but it's not necessarily going to happen for every single question. Okay? Now, math. 40 students are in math. So let's go 40 minus 20 minus X minus 15 minus X. So let's distribute that in, both negatives. 40 minus 20 plus X minus 15 plus X. And again, we get 5 plus X. Just so happens to work out like that. Not going to be like that every time. So now we have this Venn diagram with a bunch of expressions of X in it. Okay. In the original question, going back up here, 65 students will fill all 3 of these circles. Okay. So we have to make a note that math or science or art is actually going to be 65. That's going to be the total. So if we think about adding every single expression in here, 5 plus X, 20 minus X, 5 plus X, X, 15 minus X, 10 minus X, and 5 minus X, if we add up all of those numbers, it's going to equal 65. So let's go ahead and do that. Okay, 65. So 5 plus 20 plus 5 plus 15 plus 10 plus 5. I get 60. Now, X and negative X cancel. This X and this negative X cancel. This X and this negative X cancel. we're left with just an x. Okay, equals 65. Bring this over, x equals 65 minus 60, x equals 5. Just so happens to be 5, not necessarily going to match up all the time. So we have the number in the intersection is x equals 5. That means we can go ahead and label this 5. We did our work on this Venn diagram, and this is our solution. Okay, 20 minus x, I get 15. 15 minus x, I get 10. 10 minus x, which is 5, so 10 minus 5, I get 5. 5 plus 5 is 10, 10, and 10. As a check, what I would do is I would add up all of these numbers, and I would ensure that they equal 65. Okay, so we did work in one Venn diagram, solution to the other. Okay, and our answer to A, number in all three clubs, is 5. Therefore, N of M or S or, no, number in math and science and art equals 5. Now, what we're going to do here is we're going to do the exact same question, but we're actually going to use the principle of inclusion and exclusion. So, our principle states that the number in math or science or art is going to be the number in math plus the number in science plus the number in art minus the doubles. So, math and science minus number in math and art minus the number in art and science. Then we're going to add back in the triple. So math and science and art. Okay, we know that this was 65 people. Now, math, science, art, 40, 35, 30. Math and science, math and art. Math and science is 20, 15, and then 10. So minus the 20, the 15, and then the 10. And then we don't know the full intersection. So let's go ahead. I can put 40 plus 35 plus 30 minus 20 minus 15 minus 10 in my calculator. I'm getting 65 equals 60 plus the number in all three. And if we bring this 60 over and it changes to a negative 60, we get 5. And this is how we use the principle of inclusion and exclusion to do the exact same thing.